So good afternoon and welcome. My name is Dr. Cassandra Hansen. I'm the program director for the Environmental Science and Policy program at Johns Hopkins University Advanced Academic Program. You are joining us today for Sustainable Solutions, and this is our environmental speaker series. So we designed the speaker series to focus on real world problems and deconstruction of those problems and decoding of these problems by practitioners. And they're going to talk to us about how they're leveraging tools and technology from the public to private sectors that provide long-lasting solutions for these problems. And so I want to get an idea, before we jump into the presentation today, I want to get an idea of where folks are joining us. So if the folks that have joined us in the chat window, if you could please put in where you are joining from, your geographic location, that would be great. In the chat window, go ahead and provide Baltimore, excellent. DC, great. Nice to see everyone here. Welcome, welcome. Looks like we have a good group. Oakland, excellent. Well, great. This is good. So now everyone knows how to use the chat window. So if you have any comments or anything that you want to share, feel free to use the chat window. Annie and Makario will be monitoring them when they're not presenting the chat window. But I will also encourage folks to put questions in the Q&A thread. That's a great spot to actually put those questions, and then I will be giving voice to those questions at the end of the presentation. Okay, so over the summer, two of our outstanding environmental science and policy students, Britton and Makario Sarsozo, joined the NASA Develop program. And in this program, they used NASA Earth observations to address diverse environmental issues that impact our communities. So you're going to hear from both Makario and Annie today about their experience, and they're going to be sharing the projects that they worked on and provide a little bit more background about the internship program as a whole. So folks that are interested in applying, this is an opportunity to really pick their brains on how they went about applying for this process, what can one expect, and then the outcomes. So again, Annie, Makario, welcome to you both. This is one of those opportunities where we get to bring together outstanding students. You guys are almost done in graduating in the spring, so completing the program. So thank you for taking time out of your busy semester to share with us your experience. So what I'm going to do is I'm going to turn it over to both presenters today, and they're going to share with you a little bit about their background, and then they're going to dive right into their research topics. So again, let's give them a round of applause, a virtual round of applause for being here today. Thank you both, and I'll turn it over to you.
Thanks, Dr. Hansen. Annie, did you want to get started?
Yeah, absolutely. So we can just give a brief introduction of ourselves, although I know Cassie just gave it, but my name is Annie Britton. I am in my final term of my ESP master's. I'm working on my capstone right now and taking my final course. And last spring and over the summer, I participated in 2 developed terms with NASA. We're going to talk a little bit more about what the program is and everything like that, but it was an amazing addition to my experience in the ESP program. I learned a lot working between my courses and the research I was doing in the program. So I'm excited to talk more about it today. And Makario, I'll pass it to you quickly.
Hey everybody, thanks for joining us. My name is Makario Sarsozo, and I actually just finished all my coursework for the ESP program here at Johns Hopkins. And I have been transitioning from a career in television, and now I'll be working in science communication. So it's great to finally be finishing up, and also to be able to share about this program, because it was such a unique experience. It really helps build, I mean, it's called the capacity building program. It helps build technical skills, but also a lot of other research and communication skills. So anyone who's interested, definitely please reach out to us afterward.
Great. So I will share my screen and just give a little bit of an intro into the program before Makario talks about his project. So DEVELOP is part of NASA's Applied Sciences Capacity Building Program. And I think this is something that's kind of interesting to a lot of people, because prior to being a part of NASA DEVELOP, I really thought of NASA as a very space-oriented organization. I did not even know they had an earth science wing, and I didn't really know about their focus on applied earth science. But DEVELOP is seated in the Earth Science Division of the Applied Sciences at NASA. And it's a program that's built to address environmental and public policy issues by conducting research projects that use NASA Earth observations. Participants are typically placed on teams of 3 to 4 people and conduct 10-week-long research projects for partner organizations. These organizations could be NGOs, nonprofit, governmental organizations, even on occasion, international NGOs and international governments. So through this, participants are able to build capacity and learn how to use Earth observations, and partners do this as well. And this is all focused on addressing environmental challenges that face our society. In addition to this, the teams also put a lot of focus on creating science communication products, so things like videos, story maps, and technical reports to bring the research to a variety of audiences. One of the really great things about DEVELOP is that there are actually no strict educational or professional requirements in order to apply. You just need to be over the age of 18 and have an interest in learning more about remote sensing, Earth observations, and learning to use these products in research. So this means that pretty much anyone can apply. You can be an undergrad, a graduate student, a working professional, and it's also a paid program, which is fantastic. So DEVELOP as a program is nationwide. It has offices across the country, including official NASA and NOAA offices, regional offices like one at Boston University, which is number 10. There's also pop-up offices which rotate across institutions every few years. And then there's a permanent virtual environmental justice office. Some locations offer both in-person and virtual projects. Some only offer one or the other, and this usually changes based on the term. So for instance, I participated in both of my terms virtually. I'm based in Chicago, Illinois, but I participated in one term at Goddard Space Flight Center, which is number 4 on the map, and then one at NOAA's National Centers for Environmental Information, which is number 6 on the map. DEVELOP was a really amazing experience for both me and Makario, and we're really excited to talk more about it today. So with that, I will pass things off to Makario to talk about his work at Goddard Space Flight Center this summer.
Thanks, Annie. So the main ecological forecasting 3 team that I was on explored the use of Earth observations to monitor federally endangered Atlantic salmon habitat in Maine. And since this was a 3rd term, we created a workshop for our project partners to use the project data and research going forward. For this project, we partnered with the Maine Department of Marine Resources and the Downeast Salmon Federation. Downeast Salmon Federation focuses on conservation, hatcheries, long-term and land protection, and habitat restoration. The Department of Marine Resources is a state agency that works to advise local, state, and federal officials on the conservation of marine resources, and both organizations had been interested in utilizing remote sensing data to inform better salmon habitat restoration decisions in the future. A little bit about the project. Our study area focused on the Downeast salmon habitat in Maine, which is home to the last remaining wild Atlantic population in the US. And while they used to be present throughout New England and New York, they've been considered federally endangered since 2000. So our term 3 used a case study area focused on the Machias, the Union, and Penobscot rivers, which contain the last remaining run in the US. This partnership started due to community concerns in Maine that have exacerbated the rapidly declining salmon populations. Some of these concerns include climate change, as it has directly affected increasing land temperature shifts and summer precipitation, and also human-driven land use change, such as urbanization, has led to changes in forest succession patterns and changes in water quality from dam installations and pollution. So just a little bit about the first 2 terms. As I mentioned, I was on the 3rd term, and which was a little bit unusual. Most of the projects are either 1 or 2 terms. So the first term, the focus was to use NASA Earth observations to assess factors that could be attributable to the decline in Atlantic salmon. So to do this, the team created land use land cover maps for the years 1985 and 2021. And they also created land surface temperature maps to show areas, which areas were changing in temperature. And finally, the team created a precipitation map to show changes in precipitation levels from 85 to 2021. Oops. And then, so term 2, the aim of the term was to improve what was completed in term 1, and also refining the land use land cover map and delineating it by forest cover type. It also analyzed trends from the maps created to see how land cover, land surface temperature, and precipitation changed over time from 1985 to 2021. So that brings us to term 3. So for our term, we call it Maine Eco 3. We built on the previous term's research to enhance our project partners' existing endangered Atlantic salmon initiatives. So we did this by focusing on 2 main areas for our methods: knowledge transfer and community outreach. So by providing a case study area, we also demonstrated how NASA Earth observations might be used to assess salmon habitat more accurately and identify areas of concern. I say NASA Earth observations, but just to be clear, they're not all NASA satellites, as I'll get into a little bit. Sorry for the noise here. To facilitate the transfer of knowledge from terms 1 and 2, our team developed a workshop format that transfers project data and methods to our partners. We did this by walking through 3 specific tutorial areas in our workshop and provided written documentation for each. The first was data acquisition platforms and Google Earth Engine. Second was land use, land cover, and forest cover ID. That was mainly through ArcGIS Pro. And then land surface temperature and precipitation was the final one, using EcoSheds, Google Earth Engine, and ArcGIS Pro. So to achieve our other project objectives of helping our partners with community outreach, we produced a short project video addressing the status of Maine's endangered Atlantic salmon, and an impact poster that explains the pertinent issues facing Maine's Atlantic salmon populations, which our partners can use and have been using to engage the community in Maine. Excuse me. So a little bit about Earth observations. You can see here some of the different sensors and satellites that are constantly orbiting the Earth. For example, Landsat 8, Landsat 9, GPM iMerge, and Terra Modis are a few. These and other end products were incorporated into our project's research and in our partner workshop. I'll go through a few of these just briefly. The Terra Modis, for example, measures morning land surface temperature and anomalies and is being phased out in the next few years. Landsat 9 measures global landmass of both natural and human-induced changes. And then Sentinel-1 provides radar imagery for land and marine monitoring. And this is actually through European Space Agency. So again, not all, we say NASA Earth observations, but there are other sensors and satellites as well. So terms 1 and 2 of our project utilized observation data to map land cover, assess land surface temperature and precipitation over time in Maine. So as the third term, we use that data to look at a specific case study area and provide step-by-step instructions for accessing Earth observations from multiple platforms, including EarthExplorer, Earth Data, and Google Earth Engine. So I'm just going to go briefly through the tutorials that we provided to the partners. Our first was EarthExplorer, which is an online tool that allows you to access Earth science data from the archives of the U.S. Geological Survey. I'm sure some of you have used this. It includes Landsat collections, images of the Earth, high-resolution orthoimagery, national topographic and bathymetric data sets, Landsat-derived national land cover database, and natural color images from the moderate resolution imaging spectroradiometer of NASA's Terra satellite. Google Earth Engine is the next one. It's a data platform that provides a lot of opportunities to access, manipulate, access and manipulate Earth observation data. This is one of the tutorials that I did. This platform essentially organizes geospatial data for making remote sensing Earth observations accessible and useful from one place. For this tutorial, we walk through the basics of GEE and accessing specifically Landsat 8 data as an example on the platform. This project is used to generate land use and land cover maps across a particular study region over time. In the tutorial, we walk through accessing the platform, exploring the various consoles and windows, utilizing a script for accessing Landsat 8 data, which is incidentally in JavaScript, and then creating a shapefile for a specific region and ran the script to see what the data looks like visually over a specified area. I know you can't really see too clearly, but in the upper left, you see kind of the console of Google Earth Engine. And then the middle one is what would be like a visual representation of a data set. So next was the land use, land cover tutorial. It was broken into 3 sections. We covered the setup of gathering necessary data in our ArcGIS Pro to start the map, and then creating the needed indices like NDVI and NDBI, followed by making them into one raster for the image classification wizard through the composite bands function. This tutorial was actually pretty complicated and had many other steps, but that was essentially what was done. And then finally, the climate tutorial was also 3 steps. The first introduced in situ measurements using EcoShed stream temperature as an example to talk about how in situ measurements paint a more specific picture of stream temperature, but have large gaps in coverage. The second section we processed land surface temperature data in Google Earth Engine and precipitation data in ArcGIS Pro. We established a Terra Modis time series that corresponds to an EcoShed stream temperature site to see how they parallel each other. Then finally, these trends were related together to identify areas of compounding stress, such as clipping warm areas to drought areas. We also showed the basics of relating land surface temperature to land use, land cover classes to propose possible trends seen visually, for example, warm urban areas and cool water lake areas. So that was it in a nutshell. So in our analysis for the term, we found that deciduous forests increased over time in our study area from 83 to 2021, whereas the evergreen forests decreased. This may have been something to do with increased temperature, especially in riparian zones, as there's less tree cover year-round to provide the cooling effect of transpiration. We also found that developed areas increased, which may have led to an urban heat island effect and leading to further warming in Maine. And then finally, we found that the amount of barren land actually decreased, which likely stems from increased development. And so that's it for the Maine Ecological Forecasting 3 project. We can now watch a brief video, one that I mentioned we created for our project partners. And if you want, you can go ahead and play that.
The state of Maine is home to the last remaining population of federally endangered wild Atlantic salmon in the United States, and it's possible that these fish may disappear entirely. Boasting over 3,000 miles of tidal shoreline and hundreds of rivers, wild fish species have been essential to the economy and cultural identity of Maine and its indigenous communities for generations. Atlantic salmon spend their early life in these freshwater rivers and streams before they smolt and migrate to the sea. Prior to industrialization, hundreds of thousands of wild Atlantic salmon migrated back to Maine's rivers every year. However, decades of overfishing, pollution, climate change, and dam construction have reduced survivorship and blocked access to freshwater spawning grounds for this cold water species. Annual returns have plummeted to only hundreds of individuals. They are on the brink of local extinction. But this doesn't have to be the end of their story. So what is being done to save Maine's Atlantic salmon? The NASA-developed program is working with Maine's Department of Marine Resources and the Downeast Salmon Federation to use publicly available satellite data that will complement their current conservation and habitat restoration efforts. Using Landsat and Sentinel imagery to classify land use, Terramotus to measure historic land surface temperature, and GPM iMerge to study precipitation, trends indicate that conditions in Maine are becoming increasingly unfavorable for Atlantic salmon. Since the 1980s, there has been an uptick in developed and agricultural land, which reduces shade and warms nearby streams. Statewide, cool evergreen forests have transitioned to slightly warmer deciduous forests. This intensifies Maine's warming climate, especially as the Downeast region experiences less precipitation. It's still possible to prevent the local extinction of wild Atlantic salmon through habitat restoration, but this will require a multidisciplinary effort and financial investment informed by science and supported by the public and policymakers alike. Each one of us can help save these wild salmon by getting involved, sharing this information, and supporting efforts to limit global temperature increases. For more information, please visit our partners' websites.
Thanks, everybody.
Awesome. Thanks, Makario. So I'm going to turn over to the two projects that I did for NASA Develop. So my first project was between January and April 2022, and it was at Goddard Space Flight Center. And we were looking at utilizing NASA Earth observations to look at a Pinyon-Juniper tree die-off event in Flagstaff, Arizona that occurred in 2021. So for this project, we partnered with the National Park Service branch for Flagstaff area national monuments. And in mid-2021, in the midst of a pretty much decades-long ecological and hydrological drought in the region, our partner at Wupatki National Monument began to notice pinyon-juniper trees dying across the landscape. And this is pretty strange because, again, this drought had been going on for over 20 years, and typically pinyon-juniper trees are a pretty drought-tolerant species. And this also wasn't only happening in protected areas. There's news stories in local news outlets telling homeowners to water pinyon-juniper trees in their backyards. So our partners were really curious as to where and why this die-off was occurring. So in response to our partners' research questions, the team looked at pinyon-juniper trees across a nearly 2 million acre study area spanning from Flagstaff to the southern rim of the Grand Canyon, which is mapped on the right. The drought believed to be causing the mortality has been going on for multiple decades, which reduces the water availability to trees, impacting their ability to photosynthesize and makes them more susceptible to pests. Not only is this a problem for the trees, but it's troubling because these woodlands provide habitat and a food source for over 1,000 different species. And the other thing that our partners were particularly concerned about is that when large stands of trees die, they act as fuel for fires, and this increases the risk of damage to ancestral Puebloan heritage sites that they are actively managing. So to map and assess these forests, we used machine learning methods on imagery from the National Agricultural Imagery Program, which is otherwise known as NAPE, which is a super high resolution airborne data product. And we use this in conjunction with a variety of NASA satellites and sensors. So the 5 satellites and sensors you see here on the screen provided our team with data for topographical features such as slope, elevation, and aspect, as well as other variables like monthly precipitation, soil moisture, evapotranspiration, and land surface temperature for our study area. The map on the right shows pinyon-juniper mortality derived from our machine learner classification of our high resolution NAPE imagery. And the nice thing about the NAPE imagery is that we could map every single individual tree because it's so high resolution. So the percentage of tree mortality is shown on the map in shades of purple, while stands with no mortality are shown in green. White areas on the map are those that did not contain any living or dead Pinyon-Juniper trees. So you can see that spatially mortality was pretty widespread as our partners had thought, with some areas having upwards of 80 to 100% tree mortality according to our classification. Overall, our data suggests that mortality rates were within the study area were at 43%. So about that many trees had died off during this event. And rates of tree mortality within Rupatki National Monument were around 47%. So from these results, the team not only were able to map and assess this die-off, but also demonstrated that NAPE imagery is a viable option for accurately mapping tree mortality. So moving on to my second project, this was between May and August this past summer. And for this project, I was able to serve as the team lead. This project explained and examined how climatic trends were impacting the water levels of small rock pools, otherwise known as tanahas, in Organ Pipe Cactus National Monument for the National Park Service. And I have to say, both of my projects were for the National Park Service in Arizona, which was a complete coincidence, but it was great because I really got to know the area well and also work with the National Park Service, who, in my experience, were just fantastic partners. So the story of our project really begins at Organ Pipe Cactus National Monument, which is the highlighted area you see here on the map on the right. Organ Pipe Cactus National Monument is a biosphere reserve that's located in southern Arizona near the border of the Mexican state of Sonora. So while OPCNM makes up only a portion of the Sonoran Desert, its climate and geography are generally pretty representative of the desert as a whole. So the National Park Service oversees the management of these tanahas, which are ephemeral rainwater-filled rock pools, such as the Bull Pasture Tanaha, which is pictured all the way on the left on this slide. So tanahas form in exposed rock through a combination of physical, chemical, and biological processes, and are really important habitats for a variety of organisms. In this area of the desert, they're almost always one of the only sources of surface water, and they can range from shallow puddles to deep pools based on precipitation and evaporation. So this project focused on 10 tanahas within the national monument. So our approach to the project was split between two overarching work streams based on data availability. So a shorter time period for our hydro period trend analysis, which is visualized on the left, and then a longer period for our climatology time series and maps, which are visualized on the right. So we utilize various data sources throughout the project, including in situ hydro period data, which came from wildlife cameras that took pictures of the tanahas every day. And the graph on the left highlights these findings when comparing the tanaha hydro periods, which are in blue, to monthly average precipitation, which is in orange. So visually, it's pretty easy to see how precipitation spikes consistently before the Tanaha hydro period becomes saturated with water. And then the graph on the right visualizes some of our results from the climatology time series, which highlights a 3-degree increase of temperature across the monument over the past 40 years. So as we know, that's a very significant amount and was definitely a concerning finding for our partners. Even more concerning is that this rate itself is actually increasing. So over the past 20 years, the average increase was 2 degrees Fahrenheit. So both of these rates are higher than overall global rates of temperature rise. In terms of the end use for our partners, we were able to combine our results from the climatology analysis and the in situ hydro periods to allow the team to determine tanahas that were at the highest risk due to changes in climate. So in this map, we have tanaha locations overlaying a section of the daytime land surface temperature change raster. The exclamation point symbols indicate tanahas that we analyzed and thought are at the highest risk for shorter hydro periods due to temperature increase. So in conclusion, the findings of our climatology time series demonstrated that the rates of warming and drying are increasing rapidly in the Sonoran Desert. And the hydroperiod analysis demonstrates the feasibility of using climate variables to remotely monitor hydroperiod trends. So combining this in situ Tanaha hydroperiod data with spatiotemporal Earth observations would provide a way for our partners to look at Tanahas that may be at a heightened risk, and then the National Park Service can use this to inform management priorities and the conservation of Tanahas within the national monument. So that is basically an outline of the two projects I did, and I will pass it back off to Makario to talk a little bit more about develop and what those who are interested should do to learn more about the program.
Oh, great. So I was just going to mention that this is information about the program. There's actually the summer term starting soon. So if you're really interested, I would not hesitate to reach out and email the program coordinators. I'll also put in the chat this document and also a link to the application site. I'm not sure what else you wanted to talk about, Annie.
No, that was great.
Okay, yeah, so I'll drop these in the chat real quick and then we can just take some questions.
Excellent, guys. That was wonderful. What a neat process to see kind of the different teams and the different phases, and from start to finish, it really does tell a story. And so thank you guys for both sharing your individual experiences. So for folks that are here, please feel free to put questions in the Q&A, or you could also put questions in the chat, and I'm happy to put voice to them. But I'm just curious, for both of you, what was your biggest takeaway experience from this internship?
Yeah, so I can start. I think for me, one of the biggest things was just the confidence building that I had in terms of you just get thrown into this 10-week-long project. And within that span of time, you have to do a literature review. You have to figure out what methods you're going to use. And a project that might take 6 months or a year is really condensed down. And so I think one of the things I took away is that you really do have the capacity to learn how to do whatever you need to do for whether it's research or work or school. And being really excited about a project is helpful. And I think it also goes back to like a project-based learning approach. You're able to learn so much in such a short amount of time. And moving forward, I think I am really able to take that confidence and the knowledge that I can learn what I need to learn in order to do what I want to do into not just my master's and my capstone, my thesis for this program, but also just into my professional life afterwards.
Yeah, I would echo that it really allows you to understand what you're capable of, even if you don't have the specific skill set going into it. There's a lot of support. There's a ton of trainings and workshops. So even if you're on a technical heavy projects, there's coding workshops, there's GE workshops. And I mean, the other thing is that they put you in a team, like a multidisciplinary team, where you all kind of complement each other. So that was something that I didn't quite understand going into it. And I was concerned, I don't know, same thing. I don't have all these skills. But it really was a great experience because we were able to learn from each other and also rely on each other, knowing that, okay, this person, has a lot of ArcGIS Pro experience. And, I came to it with more of a storytelling and communications background. And so I was able to provide that. And that was partly why I applied to that specific project, because it was a third term and a big focus of it was conveying research and methods to our partners. So I felt like I was really able to build my technical skills, but also, participate in a way that, some of the other team members let me kind of lead on. So it was a great experience overall.
did you both feel prepared, having taken classes in the ESP program and, moving towards the end of your degree? Did you feel like the program prepared you to tackle some of these projects and work collectively and then also individually?
I think absolutely. And I think throughout the ESP program, my focus has been in like climate and conservation biology. And so for my first term project, which was the Pinyon-Juniper mortality for the National Park Service, I felt pretty confident with the background I had from ESP, knowing that I could be a contributor in like those aspects. So while I might not have like the technical coding skills or the knowledge of remote sensing, I knew I was coming in with like a strong ecology background. I had taken some conservation biology courses in the program. And so I think in that sense, it was really nice because I was like, okay, I have like, I kind of know my lane and I hope that I can expand outside of that. But I think my experience in the ESP program gave me kind of my niche in that interdisciplinary team that Makario was talking about. And it was nice because I knew like I could be the go-to person for the ecology questions. And, I had another team member who's super knowledgeable about GIS. And so we all were able to kind of pass information around and learn from each other. But I think my courses in the ESP program definitely like bolstered my confidence a lot entering, a team where everyone kind of has different backgrounds and skills.
Thank you. So to kind of jump back into the technical skill set, do you think the develop is mainly useful for you to kind of hone in your technical skill sets? Do you really feel like you were able to have an opportunity to expand your skill sets or even learn a new skill set? And can you talk a little bit about the technological side of it?
Sure. Yeah. I'll just jump in because I really did not have much experience in, definitely not in GIS. I had used ArcGIS Pro online, so I was familiar with the concepts, but I really didn't have a lot of experience using it. I didn't really have that much familiarity with remote sensing other than, understanding that NASA had satellites. And I didn't have coding experience. So I think it was really amazing to leave the program and feel like, one, I had these additional technical skills. Also, I was going into my final semester in the ESP program. So going into my GIS class, it was still a challenge, but I really had been exposed to a lot of the capabilities and just like understanding what was possible helped me kind of dive into that. Yeah, so I would say it really does expand your technical skill set, but it's hard to kind of articulate how, just because you're in this team, you are working on multiple projects, multiple documents, multiple deliverables together. So you really, you're forced to communicate on a very kind of specific technical way on a daily basis. So it kind of expands a lot of your skills, including communication and, team management, and as well as, science research and technical skill sets.
And I think also you guys got to see firsthand the application of real world, problems and using, that your background and classes and coursework and really applying that, for a real world project is so valuable. That's great. So David had a question in the chat window asking about, is the NASA program purely science-based, or is there other outlets such as policy or advocacy that one could apply for?
Yeah, that's a great question. So NASA Develop as a program is mostly focused on science and research and the communication of that. So in a sense, you may be communicating your research to people who are working on advocacy. Like I think Makario's project is a great example, working with the Downeast Salmon Federation, or to policymakers or people who are working in conservation like the National Park Service, who then will make decisions or make policy changes based on the research. However, NASA as a whole, as an organization, does not write policy or really necessarily involve themselves in policy other than providing scientific research. They like to make that distinction because they, I think, as an organization, like to remain kind of as an unbiased kind of third party that provides the science and then lets the people who are doing policy or advocacy kind of like take that and use it in their work.
Yeah, I would also just add, like, I just included a list of the proposed summer projects, and I think as you read through them, you can see that some are definitely more, they lean, like Annie said, they're not specifically relying on policy, but I think you can see how the application of them can lend more towards policy depending on what project you end up on. Yeah, and just going back to my experience with our main partners, it was interesting because they really wanted to learn this, but it was also at the same time, it was in the middle of the summer, like kind of the busiest point of their season, and so we really got to understand like what it means in theory, as opposed to people on the ground trying to, restore habitat. And so it was interesting because we had to adjust to their schedules and understand really what would be the most helpful for them, especially when we were putting together this workshop. Because, so like one of the organizations had more GIS experience, so that meant we could potentially include that, whereas the other one was like, we're very low tech, generally. So like, what are some, like, a variety of options that we can use, which is why we included the different data platforms where they could just download information, all the way through to using more technical skills in GIS.
Yeah, and I just wanted to add to that, like Cassie mentioned about like actually doing real world research. I think takeaways like that were so important because like when you're actually working with practitioners, for instance, like we were working with wildlife biologists in the National Park Service who are on the ground every day seeing these things. And I think it's so beneficial to get to work with people who really, really like intimately know what you're working on, and also can help you direct the research to something that's actually useful for them. And I think it's just an interesting comparison to anyone who's done more like academic research. So I work in like a research lab right now, and it's just the pacing's very different. And I personally find it so rewarding to work with like actual practitioners who can help you steer it, because otherwise, like, there's no guarantee that what you are working on and what you're doing is actually going to be useful to people on the ground. So I think it's a really cool program to like get that perspective and kind of take that with you. Also, I saw that someone asked if you have to be a US citizen to be part of NASA Develop. So I can pull up the map again quickly just to talk about this, because this is a really common question that people ask. But one of the nice things about NASA Develop is that you do not have to be a US citizen in order to participate. The one kind of weird thing about it is that if you would like to participate at an official NASA or NOAA office, they only will accept US citizens for those positions. However, the regional offices and the pop-up offices and the VEJ office, you do not have to be a US citizen. So if you're thinking about applying, I would recommend checking out the projects that those offices are offering and specifically applying to those projects.
That's great. Thank you. So the next question that I have, I was just wondering if you could talk a little bit about working in this field and your experience with imposter syndrome. Maybe speak about your experience.
Yeah, so I can start us off on that one. And I think this is something that I definitely experienced coming on to my first project at Develop. I think part of it was knowing that this was a very technical program, and also knowing that I didn't have those technical skills, even though that was one of my goals, like going into the program, was to learn them. I really came into my team just thinking like, oh gosh, like my teammates know so much about all of this, and like I'm so underprepared and I don't know what I'm doing. And I was really worried about not being able to like be a good contributor or a good teammate. And I think this is like a very common thing. I know a lot of people in the develop program experience this, and obviously like throughout the workplace. And specifically, I know a lot of like women in STEM or underrepresented groups in STEM experience this. And I don't think there's an easy way to like get over it. Otherwise, like everyone would be doing that. But I think with my experience, particularly just working on an interdisciplinary team from people with different backgrounds, like you kind of realize that everyone feels that way about their different blind spots in their work. And part of the reason that you're put on a team is to be able to like ask questions and learn from others' expertise and things that you don't know. And I think at first I was nervous to ask questions because I didn't want my teammates to think that I didn't know what I was doing. But then we kind of realized that we all felt that way and felt kind of silly. So I think after moving past that like hump, it's again just like given me a lot more confidence. And I think that that imposter syndrome might not necessarily ever go away, but just having that experience to know that like, okay, like everyone's kind of in the same situation, and just ask questions, be nice, be a good teammate, and like I think it really helps a lot.
Yeah, I would agree with that. I mean, just like grad school has helped me learn how to learn, in addition to all the specific knowledge. I think this was kind of like a, I don't know, like a even more intense version of that, where because it is so quick, and you're really absorbing not just data and research, but like just how to interact with people at NASA, how the organization works. So yeah, I mean, I think one thing to mention though is there's a very specific and well thought out orientation. So you really do get you get support. You also, they put a lot of importance on how everybody thinks and learns differently and brings different things to the table. Like you actually go through personality tests as kind of icebreakers, just to like really understand that people are bringing different skill sets and different ways of thinking. But I would also say that yeah, coming into it, I definitely had a little bit of imposter syndrome, specifically with the technical aspects of it, which I mean, luckily I came in after Annie, so she did help me like understand that and explain that they're they want a variety of people. So I think that helped that you explained that to me going into it, since you had done that first. But I also realized once I got there, I was like, all right, like I mean, I have my own specific skill set, and I've also had a totally different career, which happened to relate to this project in the fact that we were focusing also on creative deliverables. And it was funny, one day when we were like writing the script and finding footage, and two of our teammates who didn't have any background in this were just like, how did you do that? And I was like to me, what they were doing was incredible, and they were like, what you're doing is crazy. And that's just, it was interesting. Like everybody really appreciated what the others brought to it.
It's great. And the imposter syndrome, I get that question a lot with new students coming to the program, just because environmental science is so diverse in topics, and students coming to the program have backgrounds, Makario, like yourself, in film and production. We have folks that have a background in finance. We have folks, that are in marketing, and it's not all science-based. So it is really an opportunity to learn, and learn about the environmental sciences. So I really appreciate you guys sharing that with us. So yeah, we have, oh, go ahead.
Oh no, the one thing I was going to add to that is that I think that especially coming into in working in the environmental sciences, I think one of the most powerful things like I've learned to do is just be able to say like, oh, I don't know. Like, that's a great question. And I think that was really tough for me again, because I was like, oh, I don't want to seem like I don't know what I'm doing. But like, there's such a variety of topics that people have expertise on, and just being able to say like, I don't know. I think it's a good skill to kind of be able to admit that sometimes.
Yeah, I would also just add, it's really hard to, in an hour, kind of explain how develop works, but every team also has a science advisory panel. So you're constantly checking in with your science advisors. So if there is something that you don't know, or that your team doesn't know, like you have, PhDs there that will help you, or, researchers who have worked on this topic that can help you figure out what you need to do for that specific issue.
And then we only have a little bit more time for maybe 2 more questions. But so after the develop internship is over, I mean, is it over, or do you have opportunities to share your work elsewhere?
Yeah, so I think that, I mean, Makario and I are here talking about our work right now. So this is a great example of like, it's never really over. But I think in terms of like develop supporting you, and a great example of this was that for work, they asked for teams to submit an application to present their work at the American Geophysical Union conference every year. So over the summer, I submitted our team's work to the develop program, and then they go through all the different submissions and select the ones that they're going to submit. So ours was submitted to AGU, our abstract was accepted, and then I was able to represent our research and our team this past December. It was conveniently in Chicago, which is great for me, but I was able to attend AGU for the whole week, do a poster presentation of our research, and then also, which was really fun, I got to work the NASA booth at AGU and talk to lots of people who are interested in applied earth science and develop program, and that was, I guess, 5 months after I had finished the program. And Makario maybe can talk about this a bit more, but we were also able to present in DC at NASA headquarters this summer, which was a really cool experience. And I'll let Makario talk about that.
Sure. Yeah, I was going to say, I mean, the great thing that everyone says once you start develop is like, once you're in develop, you're always a developer, which is great because you feel part of this community. There's a LinkedIn group. There are trying to think. There are like other ways to like stay connected. But yeah, the what was it called again? The science applications week?
Earth Science Applications Week. It's a mouthful.
Yeah, so that happened to land on our last week of the project. So we gave our workshop presentation to our partners, and I think it was the next day, part of our team went to NASA headquarters, and we were able to present our project, which was amazing for me. I just, again, I don't come from a science background, so to be able to work on this research, to present it to partners in the field who will actually use it, practically, and then also to go to NASA headquarters, and our team lead did a flash talk there, and then a couple of us, along with him, also presented our project poster, and that was amazing because you realize how much you've learned. Like you're talking to a lot of NASA executives from SSAI, which is the company that I guess it's like how would you describe SSAI?
It's like a contracting
company, yeah. And then a lot of other researchers, and then your peers that have been doing other projects. So it was a really great way to kind of end that experience and to be able to share and just like appreciate how much we all learned on this project.
Oh, that's great. Thank you. So I have to ask this last question just because you guys are graduating. So advice that you have for new students coming into the ESP program, or, somewhat new, what advice can you give them since you're finishing up your time here?
I can go. I would say, as someone who came back to grad school after a long chunk of time in a different industry, I definitely had doubts. I had imposter syndrome. I wasn't even sure if I would get through the program initially. And I think, part of my advice is just like don't give up. Especially if you've been approved, if you've been accepted to the program, there's a reason why you are there. And I think even when it gets tough, which it probably will at some point, don't give up. I just think it's a great program for me. Looking back, the combination of earth science and policy is perfect. I looked at a lot of other programs, and I didn't find one that kind of had the same balance, and I think it really set me up for success moving forward.
Yeah, I 100% agree with that. And I think that for me, without being in the ESP program, I never would have ended up at Develop. I think having that background really just gave me like the confidence to apply. And I think going off of that, one of the biggest takeaways for me is that always apply. Like if you have any interest in it, apply, because one of the stories I love telling about Develop is that I found out about the opportunity, and at first I didn't apply. I was like, there's no way I'm going to get accepted. It's a lot of work. And so I put it off. And then like a week before the deadline, I was like, no, I should do this. And so I did. And it was just amazing. And I think that's a common thing that kind of people grapple with, but always apply. But my number one takeaway, I think too, is if you're just starting the ESP program or you're in the program, I know a lot of people work part-time, full-time, and are very busy in the program. But I think anything that you can do kind of outside of school to apply what you're learning in like a hands-on way, whether it's like a program like Develop, volunteering, like an internship, even just like serving on a board of an NGO or a nonprofit. I think anything you can do to like apply what you're learning outside of the program will benefit your experience in the program and what you're learning so much. And I think that's one of the fantastic things about the ESP program is that it is very flexible, it's remote. So like it just gives you a lot of wiggle room and space to kind of apply your interests, not only like in school, but outside of it. So I think anything you can do to complement your experience in the ESP program will only make it so much better. For me, that was Develop, but like it can take a lot of forms. So I would say definitely, I think like make that a priority while you're in the program.
I would just echo that I applied to several other internships and research programs and did not get accepted. And I just, like you said, like you just don't know unless you try. And it worked out with Develop, and it was a great experience. And I also have gotten involved with other environmental organizations like Sierra Club, Climate Reality Project. I think, being able to expand your network and also work on issues while you're learning in the program is a great way to apply them.
Well, this was terrific, you guys. Thank you so much. And let's give you guys another virtual round of applause. Thank you for sharing your work with us. And for those that joined us today, thank you. It's so great to see everyone here. And I can't wait to see you guys at graduation. That's going to be a lot of fun. And again, thank you for sharing your work. So with that said, I'm going to conclude our Sustainable Solutions Speaker Series. And again, thank you everyone for being here.
Thanks for having us.
Thanks so much.
Take care.